So chalo, let us begin. In the last lecture, we stopped at the phosphorus, isn't it? We did the three types of phosphorus, Sasidharan, isn't it? What were those? Yeah, you all were in the end were like this, watching like this. Yeah, those phosphorus. What were those phosphorus? The three types of phosphorus we have seen. Yeah, Ragul, red, black, and white. Correct? Red, white, black. Correct. Red, black, and white. White, red, black. Correct. And which one was the first one? Yeah, the most reactive one. The first one, the most reactive one. Yes. Sasidharan, which one was it? Correct. And which one was it? The most reactive one. Correct. The most reactive one was white. If I hit white, what do I get? Yes, Sasidharan, Ragul, and Gopinath. If I hit white, I get, correct, I get the red. Correct, Sarjana, I get the red. If I hit red, what do I get? Yes, Sasidharan. Is it black? Only black. Which black? Which black? That is also important. Alpha black.
Alpha black.
I get the, yes, Sasidharan. Who's it? Yes, Sasidharan, what happened?
No, sir.
So we get the alpha black. We get the alpha black. And if I hit the white, yeah, we get the white at 473. Correct. We get the beta black. This is where we had stopped. We have seen about the phosphorus. We have seen, correct. And this is where we have stopped. Today we are going to start with the phosphine. Yes, the PH3 phosphine. Yeah. So today we are going to start with the phosphine and then the remaining compounds. Then the remaining compounds that we will start. So phosphine. First, let us start with the phosphine. What is the hybridization of phosphine? Can anyone tell me what is the hybridization of phosphine PH3? Yeah, we have done the VSEPR in the boosters, who are there in the boosters. According to that, come on, calculate the PH3. What is the hybridization of phosphine? Yeah. Come on, calculate. Sarjana, I guess you were there, Sarjana, isn't it? When we did the VSEPR, no? Anne was there. No? And whom did I teach? I guess only one Sakti was there, I guess, yeah. So, Ragul, come on. VSEPR, anyone knows how to calculate VSEPR according? Have you heard about VSEPR, Sasidharan? Yeah? Heard, no? So, according to VSEPR, okay, I'll tell you an easy way. Okay, VSEPR. How do we calculate? Yeah, look over here. So P, it is below what? It is below what? Which element? Yeah, P is in which group, everyone? P is in which group? Yeah, P is in group, correct, group 15. Correct, nitrogen, phosphorus. Correct. So it has 5 valence electron. Correct. So according to VSEPR, Sarjana, how do we do VSEPR? I'll tell you easy way. It has 5 electrons, so I'll draw the 5 electron, 2, 3, 4, 5. Okay. Now 5 electrons I have drawn. It has 3 hydrogen that will form a bond. So hydrogen, hydrogen, hydrogen. Okay. So these are, we call it as a bond pairs. These are your bond pairs, and remaining is your lone pair. So you add that number. How many bond pair plus lone pair we have? 1, 2, 3 bond pair, 1 lone pair. So 3 plus 1, we have 4. Okay, 3 bond pair plus 1 lone pair. So 4. So you have to go like S, maximum we can have 1 S. So S. Then we have P, so 2 number. SP2, that means 3 number. And SP3, that means 4 number. Are you getting it, everyone? If it was 5, then it could have been SP3D. If it was 3, then it would have been SP2. It is basically number of hybrid orbitals, nothing else. Okay. So SP3 hybridization. Is it clear, everyone? Correct, Sajna? It is SP3 hybridization. And for the SP3 hybridization, what is the geometry? Everyone, what is the geometry for SP3 hybridization? Yes. Sashidharan, Ragul, Gopinath, Sindhuja, Prashanti. What is the hybridization for SP3? What is the hybridization for SP3? Sorry. What is the geometry for SP3? Not hybridization. What is the geometry for SP3? Everyone? No one knows? Correct? Correct, Shasidharan, correct. And yes, it is nothing but your tetrahedral. Yeah. That's why over here you can see this is your pyramid, and if I draw which is the lone pair, this becomes a tetrahedron. Yeah, this look like a ghost, but those are not eyes, those are the lone pair. Okay, those are the lone pair. So this is a tetrahedral structure. PH3, it is sp3 hybridized, and it contains tetrahedral geometry. Is it clear, everyone? Yeah, come on, give me yes or no. Is it clear? Yes. So that is how your VSCPR works. So phosphine, how do we find, how do we prepare phosphine? How do we prepare phosphine? So see, when you have calcium or alkali metals with oxygen, we call them as oxides. When they are attached to nitrogen, what do we call them? We call them as nitrides. When similarly, when they are attached to the phosphorus, we call them as phosphides. We call them as phosphides. Correct? So phosphide, calcium phosphide, for example, calcium phosphide. Now calcium phosphide, if I hydrolyze it, look over here. Every time, remember, when you have a alkali metal and you are adding water, when you are having alkali metal like you have sodium, potassium, your alkaline earth metals, calcium, whatever you have, when you add water, always and always remember you'll get the hydroxide. You'll get the hydroxide. So over here, if I hydrolyze the calcium phosphide, what I'll get? Calcium hydroxide and a phosphine Come on, write down this preparation. Yes. So again, I take calcium phosphide. If I hydrolyze it using acid, if I acidify it, come on, calcium again positive, chlorine I have negative. So calcium chloride again attaching to each other and a phosphine. Is it clear, everyone? Yeah. And what is the oxidation state of phosphorus over here? What is the oxidation state of phosphorus over here? Come on, tell me. Oxidation state of phosphorus in the calcium phosphide, what will be the oxidation state? Yeah. Sashidharan, Gopinath, Sindhuja, what will be the oxidation state of phosphorus over here? No one knows? Correct. Sajna, what will be the oxidation state of phosphorus over here? Yes, Ragul, Sindhuja, Sashidharan, what will be the oxidation state of phosphorus over here? Yeah. Prashanti, what will be the oxidation state? Oxidation state means charge. What will be the charge on phosphorus? It is an ionic molecule, no? So calcium is 2 plus, phosphorus is 3 minus. So this is the phosphorus is in -3 oxidation state. Yeah. Come on, write down this to preparation quickly and tell me done in the chat box. Write it down and done in the chat box. Write it down to preparation and done in the chat box. Important. Okay, these are important. Can come in the exam in the statement type of questions. Yeah. Very common in the statement type of questions. Okay, and it's done. Raghu, you are not writing. Show me your book and pen in the camera. Show. Ah, yeah. Go bring book and pen. Where is it? It is the diary. Show again. Show again. Okay. Okay. Chalo. Similarly, we have the laboratory preparation. Again, I told you laboratory preparation with what? What happened to my English? Laboratory preparation means what? Yeah, laboratory preparation means we prepare it at a small scale. So over here again, I take the phosphorus. Now, as I told you, oxygen is it generally in the O2 state, correct? Fluorine is in the F2 state. Similarly, if I have phosphorus, it will be in the P4 state. Yeah, phosphorus in the natural nature, it is in the P4 state. Correct. So if I add the sodium hydroxide and I add the water, basically I am hydrolyzing it in the presence of a base. So again, what I will get, again the same thing. Similarly, I had hydrolyzed phosphorus over here also. Again, what I'll get the phosphine and the sodium hypophosphite. What I'll get? Sodium hypophosphite. We have the structures in the, when you go ahead, we will have the structures of this, but right now write it down. When I hydrolyze the phosphorus using a base, again what I'll get the phosphine. Again, I'll get the phosphine. I get the phosphine. Come on, write it down. Write down this. Then again, if I react it with PH4I, yeah, if I react it with PH4I, this is, if you have not seen this, I'll tell you, this is your phosphonium iodide. What do we call it? Phosphonium iodide. This is your phosphonium iodide. So again, you treat it with base. So you have alkali and you have a halogen. Alkali metal halogen, as I told you, they are lovers, always come together. So Ki, H2O, and again a phosphine. So these four are the important preparations of phosphine. Okay, important preparation of phosphine. Come on, write it down. Write it down and done in the chat box. Then we'll go ahead. Come on, write it down. Yes, done. Yes, okay, chalo. Let us go ahead. Okay. Now you have few more preparations from phosphorus acid. So phosphorus acid, that is your H3PO3. Okay, we have all the structures regarding this, but first understand the reactions from the phosphorus acid. Yes, from the phosphorus acid. Again, if I heat it, yes, they combine with each other. Again, they will combine with each other to give you phosphoric acid, and the phosphine will be lost. Will be lost. Similarly, phosphonium iodide we have already seen. If I add the base, in the phosphonium iodide, what I'll get? Again, I'll get the phosphine. Simple. Yeah. And how do we prepare this phosphine? Is we just simply react phosphorus and iodine. You'll get the phosphine. Okay. Simply react phosphorus, iodine, and add water. You'll get the phosphine. Okay, not phosphine, sorry, phosphonium iodide. Okay, so phosphonium iodide, if I add the base, everyone, what do I get? I get the phosphine. And how do we prepare phosphonium iodide? Yes, we have the phosphorus, hydrogen, and iodine. So similarly, react it with the same thing, phosphorus, iodine, and water. Okay, what do we get? We get the phosphonium iodide. And from that salt, if we add the base, we get the phosphine. Come on, write this down. I'll give you the important reactions to write it down. Okay, others are fine. Come on, write it down and done in the chat box. Write down the reaction, done in the chat box. Done. Archana is done, and is done. Tell me one thing, is there any festival now in the south around 25th, 24th? Yeah. Which festival is it? Like, one of my colleagues, she is from the south, she has taken a holiday on that day. Oh, 'Oh, 'Onam is on 29th. No. 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 'Oh, and it is Tuesday itself. So will you be attending lecture? Tell me honestly. Hmm? On 29th, Onam. We might, I do not know. I do not know that we have holiday or no. Not sure at all. Because last Onam there were very few students who we had decided not to continue with the lecture. Like last year, I am talking last year. Okay. So I do not know about this year what these people have thought of. Let's see. But I did not get yes from anyone. Huh? Only Prasanthi has written yes. Not sure. Yeah. What do you do in the Onam? Like, do you go out or what? No, no. You are at home only generally. Yeah. You are at home only. You prepare good food. You eat it. Yeah. Generally, there is a thing no where all the peoples gather, like the family members, and they eat together on the banana leaf. Yeah. Hmm. Because I have few friends and like I go at their places to eat. Chalo. Let us go ahead from this. Yeah. And you will be shocked to know even my roots are from South India. Like my ancestors were from South India. Okay. We migrated to the Maharashtra Konkan coast. Yeah. So yeah, I have roots from the South India too. Okay. Chalo. Phosphine. Yes. What is phosphine? We have studied about phosphine so much. So, acha, send very first. Okay. So phosphine, what is exactly phosphine? Phosphine is nothing but colorless gas. Yeah. Rotten fish smell poisonous. So imagine rotten fish smell. First of all, smell of a fish, which is already yuck. Yeah. And on top of that, rotten fish. Imagine. A vegetarian cannot even imagine this. Rotten fish smell. Yeah. It explodes in contact with the traces of oxidizing agent, so it is explosive. If it comes in the contact with oxidizing agent, even if it comes with the contact of oxygen, there is a possibility it may explode. Okay. So yes, it is explosive. Your phosphine is explosive. Okay. Now look at this. If you do this, okay, if you do this box, if you do this, your whole reaction of phosphine are covered. If you do this, the whole reactions of phosphine are covered. Okay. So what is happening over here? I'll explain you. See, phosphine, if I react it with oxygen, that means I am reaction with oxygen is nothing but oxidation. So if I oxidize the phosphine, what do I get? Phosphoric acid. If I heat the phosphine, yeah, it decomposes, and what I will get? I will get phosphorus. Like only two things are there in phosphine, phosphorus and hydrogen. And that is what we get if I heat it, phosphorus and the hydrogen. If I chlorinate it, obviously chlorinating agent attack will at P, and I will get PCl5 and HCl. Yeah. If I react it with copper sulfate, what will happen? I will get phosphide. Yes. Reacting with silver, again the phosphide. Then I reacted with HCl. Yeah. It has a lone pair, isn't it? So pH3 will act as a base. Yeah. It can act as a base if I have pH3. We have seen it has a lone pair. Yeah. And according to Lewis base, what is a base? What is a Lewis base? According to Lewis, what is a Lewis base? Sarjana, Sasidaran, Gopinath. What is the Lewis base? Yeah. Yes, correct. Which donates the electron. And that's why it is reacting with acid. Donates the electron. It's get added pH4 plus Cl minus. Okay. Same is with Hi, pH4 plus I minus. Okay. Is it clear, everyone? So just doing this much cover all of the reactions of phosphine. Chemical properties of phosphine covered. See, in the exam, how will you remember? These are very difficult to remember. Trust me, so many, like it is way difficult for, like not difficult, but way tedious even than organic chemistry. In the organic chemistry reactions, at least you have some logic. So this nucleophile is attacking. Yeah, this hydrogen is lost. Yeah, this is the base. It will remove proton. It is acid. It will add a proton. Over here, there is no such logic. If this reaction is happening, your inorganic reactions are like that only. If it is happening, it is happening. You cannot, you cannot have anything else. Yeah. So you have to make tricks like this. Okay, because there are so many reactions and it is difficult to remember by making without any trick. You have to make it in short, all the reaction, find a connection, and all the chemical properties, I'll say you study like this. Then only it is possible. And how will you study? Phosphine on oxidation gives phosphorus acid. Phosphine, when you heat it, decomposes to phosphorus. Phosphine on chlorination, chlorine gets added. That is how you remember the reactions. Otherwise, it is very difficult. Is it clear, everyone? Yeah? Yes or no? Come on, give me yes or no. What, in first half an hour only you have gone? Dull? Yeah? Chalo. So, phosphine, if you react it with copper sulfate, mercurous chloride, yes? So, these are some of the uses of phosphine, that when you react it with copper sulfate, yeah, we get copper phosphide, mercurous phosphide, yeah? And this reaction we have already seen. Okay, so these are the uses of phosphine. Over here, these are not the uses. This should be the reactions. Yeah. Uses. Now, as we have seen, phosphine. Yeah. How many of you have seen Titanic? Anyone? Most of you. Yeah. Come on, raise hand option. How many of you have seen? Yeah. All of us. Only two have seen Titanic. What is this? Sasidharan? Have not seen Titanic? Yeah. No. Seen no. Prashanti? Yeah. We get envy of Rose and Jack, isn't it? How cool and how good they look, isn't it? Yeah, isn't it? Yeah, the Jack and Rose, how beautiful they look, especially both of them, like both of them, even Jack, his hairstyle and everything, he looks so nice. Yeah. So why we are talking about Titanic is not because of Jack and Rose, is because uh, if you see, like whenever you go by ship, okay, they, in case of emergency, they use something to signal the, to signal people. They use something so that if someone is very far away, you can see it. Yeah. So this phosphine is used in that. The phosphine, this whole signal, what is that? That is the same thing. Yeah. It can, even if you drop it on the ocean floor, no, if you drop it on the ocean, it will still burn on the top of ocean. Yeah. So that is a whole signal. Yeah. Because phosphine, as I told you, is very reactive. If it combines with oxygen, it may explode. So this spontaneous combustion, yeah, we take advantage of that. We take the advantage of that, and it even burns on the water. Imagine. Yeah. So in the ship, in the all these crews, they use this whole signal to call for help. To call for help, they use the whole signal. That's why I was talking about Titanic, not due to Jack and Rose. Okay. Then it is also used in smoke screens. How many of you play games? Yeah. Ragul, Counter Strike. Is it so? Sasidharan, your face looks like you play games. Yeah. 100%, isn't it? Okay. So in that we use the smoke bombs, isn't it? We use the smoke bombs so that the visibility of the opponent goes down. That smoke screens, in that smoke bombs, what do you have? You have the phosphine. Yeah. You have the phosphine to, so that the smoke bombs will burst and you will have all the smoke in front of you and the opponent cannot see you. So smoke screen, yeah, thrown in the sea and they burn as a signal. So that is a whole signal, and that is a use of phosphine. Okay, something different, so it can come. So remember, for the statement type of questions, it can definitely come. Okay, clear everyone? Come on, give me yes or no. Is it clear? Is it clear? Okay. Prashanti, is it clear? Prashanti? Okay. Shall let us go to halides of phosphorus. We know the two halides of phosphorus, that is px3 and px5. Yeah, phosphorus trihalide, phosphorus pentahalide, phosphorus trihalide, phosphorus pentahalide. Correct. So let us see what is this phosphorus trihalide and phosphorus pentahalide. Now simple. We are forming phosphorus halide. How we will form? Simply reaction with chlorine. Do we have any other way? Yes? No. Simple reaction with chlorine. Yeah, reacting with chlorinating agent. Yeah. For example, if I react chlorine and the phosphorus. Yeah, if I react chlorine and the phosphorus, what I will get? PCl3. And if I take excess of chlorine and I continue the reaction, yeah, then I will get PCl5. Okay, then I will get PCl5. Is it clear, Prashanti? Prashanti, am I audible to you? So, if I react phosphorus and chlorine, what I'll get? Phosphorus trichloride. If I take excess, I further continue the chlorination, Sasidaran, what I'll get? I'll get the PCl5. Yeah. Then similarly, thionyl chloride. Thionyl chloride is like this, SO. Just like carbonyl you have, so we call this as thionyl, thio, sulfur, thia. Sulfur is also called as thia. Okay, that's why we call it thionyl. So I have Cl, Cl. So if I react phosphorus with thionyl chloride, again what I will get? PCl3, your sulfur dioxide, and H₂SO₂ is lost. Okay, so basically our important product is PCl3, PCl3, PCl3. And again, if I take it in excess, what I will get? If I take it in excess, I will get PCl5. Again, if I continue the reaction, take it in excess, what I'll get? PCl5. Okay. Now, just like pH3, come on, tell me PCl3, what will be the hybridization, Sasidaran? And Sarjana, Ragul, come on, tell me, just like PCl3, just like pH3, what will be the hybridization of PCl3? Yeah. According to VSCPR, what will be the hybridization of PCl3? Anthony? Correct. What will be the hybridization of PCl5? PCl3 and PCl5. Sasidaran, what will be PCl5? You were there, Sasidaran, in the booster, I guess, while doing VSCPR. Were you there? Yeah? That's why he is able to answer so quickly. Yeah, yeah, correct, and correct, Sarjana. Yeah, it is sp3 and sp3d. Yeah. So PCl3 same like pH3. Yes, again what I will have, everyone present, stay, look over here. PCl3 phosphorus contain again 5 valence electron. So 1, 2, 3, 4, 5. Cl, Cl, Cl. Correct? And I have a lone pair. So 3 bond pairs and a 1 lone pair. So number is 4, 4 number means sp3, and sp3 means tetrahedral. sp3 means tetrahedral. So that is how your PCl3 look like. sp3 hybridization, PCl, sigma bonds, yeah. And when we are doing the shape, yeah, in the shape we do not consider the lone pair. For example, this is my tetrahedral, correct? This is my tetrahedral, but for the shape, geometry is tetrahedral. Understand, there is a difference between geometry and there is a difference between shape. Geometry, yes, it is tetrahedral, which includes the lone pair. In the shape, write it down, exclude the lone pair. In the shape, exclude lone pair. So if I erase this lone pair, everyone, I'll erase the lone pair. What I have got? I have got a pyramid. So that is your pyramidal structure. Pyramidal structure. Is it clear, everyone? Come on, give me yes or no. Is it clear? Yeah, is it clear? Okay. Now look over here. So just like I gave you the phosphine chemical properties. Yes, Sasidaran?
So like why we are removing the electrons, like lone pair of electron in the shapes? Any reason, or like generally we do so?
No, no, no. It is a rule. See, geometry is a different thing. On the basis of hybridization, we define the geometry. Okay.
Yes.
Shape and geometry are two different, completely different things. Okay, they are not the same thing. Okay. For the shape, the arrangement can change. Okay, the arrangement can change, and that's why we do not consider the lone pair. Again, we do not consider the lone pair means what? We do not erase it from our VSCPR. We do the VSCPR exactly like that. We draw the geometry exactly like that. Only for the shape, we do not consider the lone pair, and that is the rule. Okay, that is the rule. We do not consider the lone pair, just draw it and erase it. Okay, but that does not mean we do not consider over here in the VSEPR. We have to consider to find the hybridization correct. If we do not consider over here, our hybridization will be sp2, which is incorrect. Are you getting it, Sasidaran?
Yes, sir. Yes.
Okay. Okay. Now look over here, everyone. Just like we did a box for pH3, these are all the chemical properties of PCl3. Look, so many reactions. Yeah. All the chemical properties of PCl3 again. Again, how you have to do it? Look over here. That comma means what? They are reacting with each other. See, if I have PCl3, I have combined them together in a single box. This will be very, very helpful. All of the reactions at a single place. Yeah, all of the reactions at a single place. Very, very helpful. Okay, so over here again same thing. PCl3 reaction with water. Yeah, reaction with water. So what I will get? H3PO3 and HCl. H3PO3 and HCl. Are you getting it? H3PO3 and the HCl. Similarly, PCl3 and the oxygen. Oxygen get added, POCl3. PCl3 and SO3 gets added, POCl3, SO2, oxidizing agent. Yeah, PCl3 plus Cl2, PCl5, already seen it. So if you do this table, again I'm telling you, okay, in the textbook, it is not given like that. If you open the book, all the reactions are scattered. What I have done, I have collected them and I have put it in a single box. So if you study this much, all of the reactions of PCl3 are done. Are you getting it, everyone? Yeah, all of the PCl3 reactions I have combined from the reference book, from the textbook, combined it, clubbed it at one place. If you do this, chemical properties done, just like your pH3. Yeah, is it clear? So kindly go through this. Yeah, if you find any difficulty, I am there. Try to make your own shortcuts, try to make your own short versions. More short versions you will make, more easy to understand, because already we have chemistry so much. Yeah, yes, Sasidaran, what happened? Just a minute, everyone.
Okay, sir.
Yes, Sasidaran, what happened?
Sir, in this table, the last reaction they have given metal and like phosphorus chloride. Generally, PCl3 will use no, sir. So
No,
in
no,
the
no. Yeah, go ahead.
so the metals will be in like normal general state or will be in oxides.
See, no. Look over here. Simple metals, your simple metals. Like for example, if I have phosphorus chlorides, okay, let us say PCl3, okay, and I reacted with metal like Na, like Ca, okay, what you will get always and always. I have told you metal, yeah, all the alkali metal, alkaline earth metal, yeah, and you have a what we say you have a halides, yeah. So always and always your metals and halides, they are going to come together. For example, over here you will get NaCl
NaCl.
and you will get phosphorus. Yeah, are you getting it?
Yes, sir.
So metal chlorides you get as a major product over here. Okay, that is what written over there. Getting it,
Okay, sir.
Sasidhar? Okay, so do not keep on writing, it is fine, you can copy it afterwards. You have the PDF with you only. Yeah, not going anywhere. PDF is with you. Yeah, so I want you to sit down separately after the lecture, take this and write these reactions after the lecture, so that it will go inside your head. Clear? Shallow. So phosphorus trichloride, it is a colorless oily liquid. Yes, obviously it is a liquid. What do you mean by specific gravity? Anyone knows? What is specific gravity? Yeah, Sarjana and Sasidaran, Gopinath, Anthony. What is specific gravity? Prashanti, what do you mean by specific gravity? Gravity is same only, no? What is specific gravity? Yeah. specific gravity is nothing but density. Okay, in specific gravity, remember, specific gravity is nothing but density. Okay, so density is 1.6 gram per cm cube. Okay, gram per cm cube. That means basically it is heavier than water. So it is a colorless liquid, and if I have a water and I add this, okay, it will go and settle down below. Okay, so it is specific gravity is 1.6. It is heavier than water. That is the meaning. It has again highly pungent smell. Highly pungent smell. Okay. Now look at this PCl5 sp3 hybridize. sp3 hybridization. What is the geometry? Do I know? sp3d hybridize PCl5. What is the geometry? Yes, Sashidharan, Anthony, Prashanti. What is the geometry of PCl5? That is sp3d. Pyramidal, does it? That was PCl3, Prashanti, not PCl5. PCl5 sp3d. Yes, that is everyone TBP. What is TBP? Trigonal bipyramidal. Trigonal bipyramidal. Trigonal bipyramidal. Okay, trigonal bipyramidal TBP. Look over here. sp3d hybridization. This is your TBP. Why we call it TBP? Look over here. This is a triangle. A, B, C. This is a triangle. Yeah, chlorine down, chlorine up. If I join this, it makes a pyramid. Yeah. So one pyramid at the top, one pyramid at the bottom, one pyramid at the bottom. Yeah. If I join this, one pyramid at the top, one pyramid at the bottom. Yeah, that's right. Trigonal, that means triangle in between, pyramid at the top, pyramid at the bottom. So trigonal bipyramidal. Is it clear, everyone? Trigonal bipyramidal. Okay, trigonal bipyramidal. And these bonds, these are called as axial bonds. The one which is at the top and bottom, they are called as axial, and these are called as equatorial. Axial and equatorial. Now, axial bonds are larger than the equatorial bond. That means what? Who will break first? If I do any reaction, will the axial bond break first or will the equatorial bond will break first? According to this statement, what do you think? Correct? Because larger the bond, it is easy to break. Larger the bond, it is easy to break. All of them are single bond. Correct? So larger the bond, it is easier to break. So therefore, axial bond are less stable. Yeah, axial bond are less stable than equatorial bond. Simple. Yeah, axial bond are less stable than the equatorial bond stable. Are you getting it, everyone? Come on, give me yes or no. Is it clear? Yeah, axial will be less stable than the equatorial because the size of axial is larger, the distance is larger, so it will break easily. Yeah, so this is what I have told you. P4 10Cl2 excess of chlorine if I take. Yeah, excess of chlorine. That means what? First I will get PCl3. I react P4 plus Cl2. I will get PCl3. I will react it with chlorine again. That is excess of chlorine and get PCl5. So same thing. SO2Cl2, Cl2. What we have seen in the last uh, reaction where we prepared PCl3. I have used extra Cl2. That's it. If I use more chlorine, I will get PCl5. If I use the equivalent chlorine, I will get the PCl3. Simple. Okay, do not make it complex, very simple. Okay. Now physical property, yes, it is a yellowish white powder. It fumes in the moist air. Okay. It sublimes. What is sublimation, everyone? Yeah. What is sublimation? Yeah, what is sublimation? It sublimes. What do we mean by sublimation? Yeah, I hope everyone knows it. Prashanti, what do we mean by sublimation? Anthony, Ragul, what do we mean by sublimation? Yeah, directly, Ragul, sublimation. Sublimation means what? Alright, no one knows. Sashidhara, sublimation means? Ah,
Sir, like solid to gas conversion.
solid to gas conversion, direct conversion. Okay, so it sublimes at the 433 Kelvin. If we convert solid directly to gas, yeah, so it is a sublimable solid. It is a sublimable solid. Okay, now again, look over here. Again, again, chemical properties. Okay, again the chemical properties. Yeah. So all these chemical properties, just like your pH3, we have seen pH3, we have seen PCl3. Same is the case with PCl5. Same is the case with PCl5. See, these are the completely organic reaction. They may not come in the inorganic. Yeah, they are the completely organic reaction. What are those? Acid. Yeah, acetic acid, CH3COOH. So your PCl3 and PCl5, write it down. They are the chlorinating agent. You will study that in the organic acid, organic chemistry. PCl3 and PCl5, they are the chlorinating agents. Yeah, chlorinating agents. What happens? You get the Cl minus from that. Cl minus comes, it attacks, closes, goes. So what did you get? CH3, COCl. Yeah, so it basically replaces the OH. It replaces the OH. And that is the exact thing written over here. See, you have the OH, you have the Cl. Yeah, so if you react it with PCl5, yeah, OH will be replaced by Cl. Similarly, you have alcohol, OH will be replaced by Cl. Yeah, because it is a chlorinating agent. Yeah, it is a chlorinating agent. And if you heat PCl5, it will decompose into what? It will decompose into PCl3 and Cl. It will decompose into present C, PCl3 and and Cl2. Now what is this reactant to reactant phase? That is if I do the reaction continuously. Okay. If I carry on the reaction, this products I will get. This products I will get. So again, this is again one more chemical property that you have to write it after the lecture. Yeah. So what do we have? We have pH3 chemical properties. We have PCl3 chemical properties, and we have PCl5. So I have clubbed everything from the textbook, reference book. You do not have to do anything else than those chemical properties. That is enough. Is it clear? Anthony, Prashansky, Sajna, and Sasudharan, is it clear? Yeah. So please take out your time and write it down. I know you are very busy, yeah, with the school work also, but take out only half an hour. That's it. Half an hour, 1 hour. It is fine. Okay. Then we have seen this Hone signal. Yeah, most reactive. That is also seen. White and black is the least. Then PCl4, PCl6. Yeah, we have seen this in the last lecture. That in the solid state, in the ionic form, they are present as PCl4, PCl6. Now, okay, PCl6. Huh? Let us talk about this. PCl6, PCl6 minus. What will be the hybridization according to VSCPR? PCl6 minus. What will be the hybridization? I'll give you one hint. Negative charge means you have to add an electron. Come on, go ahead. Prashansky calculate, Anthony calculate. PCl6 minus, according to VSCPR, what will be the hybridization? Come on, calculate. If I have a negative charge, Sasidaran, that means I have an extra electron. Yeah? Come on, calculate. PCl6 minus. What will be the hybridization? Correct. And negative means you have to add an electron. The extra electron you have. Correct, Sajna? Yes, everyone, PCl6 minus. Again, over here, phosphorus, PCl6 minus. Phosphorus, yeah, PCl6 minus, phosphorus. How many electrons you have? You have the 5 electrons, correct? You have the 5 electrons, extra negative charge makes it 6 electron. 1, 2, 3, 4, 5, 6, and you have the 6 chlorine, correct? So this 6 lone pairs you have, 6 number means what? You have 1, 2, 3, 4, 5, 6. That means S, P3 makes it 4. If I add D, it will make 5. D2, it makes 6. So sp3 D2, that is your octahedral. Is it clear, everyone? Come on, give me yes or no. Is it clear? Yeah, is it clear? And similarly now, chalo, tell me for PCl4 plus. PCl4 plus. When it is plus, you have to remove an electron. A hint. Come on, go ahead. PCl4 plus. PCl4 plus. PCl4 plus. Correct, Sajna? PCl4 plus. Come on, Sashidharan, tell me. PCl4 plus. Yes, correct, Sashidharan. And what will be PCl4 plus? You have, it is plus means you have to remove one electron. That means instead of 5, what we will have? We will have 4 electrons. So 1, 2, 3, 4, and 4 Cl. Are you getting it, Ragul? Cl, Cl, Cl. 4 means sp3. Total number is 4. Okay. Sure. Let us go to our today's PPT. What is our PPT? Let's see. So that was about your group 15. Okay, that was about your group 15. Today we are going to start it with the group 16. Let us start with the group 16. Let us start with the group 16. Okay, these questions I am going to take it all together. Okay, let us start with the group 16. So group 16, what is the first element? Yes, first element of group 16, Sasidaran and Sajna. Oh, oh, yeah, oh, yeah, correct. Oh, yeah, oxygen is the first element, and we all know how important is oxygen, isn't it? Yeah, try to stay for more than 2 minutes with your nose closed. Is it possible? No, do not try it. Yeah, otherwise you have to run to a hospital and I have to go to jail. That my teacher has told me, yeah, to stop the oxygen supply to our body for 2 minutes. So I am stopping it. Yeah, you will stop it. You will sleep fine afterwards, but I have to sleep in jail after that. Okay, so do not do it. But I can give you one experiment. Okay, tell me, fish. Yeah, all my bio people, fish. What do they breathe? What do they breathe? What do fish breathe? What do fish respire? Not breathing, respiration. What do the fish respire? Yeah. Oh, okay. Now, I do not know I have discussed this or no, but there is one experiment you can perform. How many of you have fish tank at home? Raise hand. Anyone? Fish tank at home? Prashanti, you have fish tank at home? Yeah. Who cleans your fish tank? You or your parents? Yeah, definitely it is parents. You do not do it. Yeah. Okay. We do not do that hard work. Yeah. When our parents tell you to do that, we are studying at them. Yeah. Okay. So you can consider this as an experiment. Okay. Now do not try this, but yeah. So I have a beaker. Acha. Okay. I have a beaker. Okay. And I have a glass beaker or a glass vessel, anything. Okay. And I have water into it, and I boil that water. Okay. I have boiled that water, and I have boiled that water. After boiling that water, I have closed it and I have allowed it to cool it down. I have allowed it to cool it down. It will slowly and steadily, yes, it will cool down. Okay. Now, as it cools down, I'll open the vessel. I'll open the, uh, as it cools down, I'll open the vessel and I'll put the fish inside it. I'll put the fish inside it. Will the fish survive or die? Anthony, Prashansky, Sarjana, and Sasidaran, what do you think? First of all, it will not die because of heat or it will not survive because of heat. Do not consider heat as a factor. Okay. What do you think? Fish will survive or die? Come on, tell me. Survive or die? Survive or die? What do you think? Will fish survive or will the fish die? Ragul, I know your favorite food is fish, but the fish that is in the fish tank, we do not eat it. Yeah? Hmm. Come on, tell me, fish will, what do you think? Tell me your observation, it is fine even if it is wrong. Will the fish survive or will the fish die? Survive or die? Okay. Some of you say survive, some of you say die. Come on, tell me, Sasidaran, Sarjana, what do you think? Prashansky, what do you think? Will the fish survive or die? Anthony, Ragul. Okay, some of you say die. Why will it die? Like, isn't it already in water only? Why will it die? Yeah. Half condition. What half condition? What more knowledge you require? Tell me. I'll give you the condition. Why will it die, Sasidaran? Because if it would have survived, you will not ask this question. Yeah. If it was not interesting and if the fish could survive, I will not ask the question. That is also correct. Why will I ask the boring question that if I put for what fish in the water, will it survive or no? Yeah. If it survives, then it is a boring question. Why are you even asking? Yeah. Yes, correct. See, when I heat it, yeah, when I boil it, okay, do you see like in the chemistry lab, yeah, when you boil a water which is in the beaker, you could see the bubbles from the corner. Yeah, you could see the bubbles from the corner. Forget about dissolving. The oxygen which is already present inside water, okay, it escapes. These bubbles are nothing but the oxygen gas. Okay, this bubble is nothing but the oxygen gas. And oxygen already does not have high solubility in water because oxygen is kind of non-polar. Yeah, and because you have same exact thing, oxygen, so it is kind of non-polar. Okay, and water is polar, so already it does not have high solubility in water, and whatever little bit is present which fish takes, which fish respires, you have boiled it and you have let it out. Yeah, so in the water there is no oxygen. Yeah, now obviously fish do not take this oxygen. Okay, if you are confused, then close your chemistry book and burn it. Okay, this oxygen is not for breathing. Yeah, that is the water molecule. Fish do not take that oxygen. Fish take the oxygen which is dissolved in it from the atmosphere. Whatever oxygen which has gone into water and is dissolved, that oxygen fish take. And if you remove all the oxygen by boiling, the fish will die. Fish will not survive. Is it clear? That's why we never put extreme clean water. Prashant says extremely clean water in the fish tank. Yeah, there is a possibility that our fish might die because it does not have that much of oxygen. Is it clear, everyone? Yeah, is it clear? Hmm. Okay. Chalo, let us do oxoacids. Okay, so let us take a break. Yeah, after break, let's do oxoacids. Yeah, what is the time? 8, exact 8. Oh my god. Till what time should I give break? So I want back by 8. Okay, so that we can start by 8, 9. Chalo. Yes, are we back, everyone? Come on, are we back? Come on, back in the chat box. Come on, turn on your cameras. Are we back? Ragul, Anthony, Sasidaran, and turn on your cameras. Come on. Come on, back. What happened? I did not give you a break till 10. It was break till 8. Yeah, in which you have already ate 2 minutes. Yeah, Anthony. Sure. Let us continue. Yeah. Now next we have in the phosphorus your group 16. What we have? Yeah, group 16. What we have? All these oxoacids. Important. Now in this, what question comes? First thing, you should know the structure. I'll help you to how to write down the structure. Okay. So what kind of bond you have, what structure you have, that structure comes in the exam, like which kind of bonds are present in the structure, and they will not give you the formula. With the formula, it is easy to draw the structure. They will know what is this phosphinic acid. You should know what is phosphonic acid. You should know what is pyrophosphorus acid. Yes, so one by one, let us see what is the structure and what is the name. For example, if I have H₄SO₄, H₄SO₄, yeah, what is the oxidation state of phosphorus over here? Come on, everyone, calculate quickly. Oxidation state of phosphorus, H₄SO₄. Siddharan, what is the oxidation state of phosphorus over here? Prashanti, come on, calculate. Oxidation state of phosphorus. Okay. Sarjana, correct. Prashanti, do you know how to calculate? Come on, calculate. Anthony, what happened? You take extra 5 minutes. Come on, calculate the oxidation state of phosphorus. Prashanti, how to calculate? What is it? So over here, P, I'm calculating the oxidation state for P, Prashanti, so I'll consider it as X. How many P I have? I have 2x. How many hydrogen? Charge on hydrogen is +1. So +1 into 4 is 4 plus 2x. Charge on oxygen is -2. 6 oxygen we have. 6 into -2 is -12 is equal to 0. So 2x is equal to 12 minus 4. Yeah. So 2x is equal to 8. So x is equal to 8 by 2, that is +4. Correct? 8 by 2 +4. Now look at this. H3PO2, hypophosphorus acid or phosphinic acid. Hypophosphorus or phosphonic acid. H3PO2. Now just like look over here, everyone, just like we have H₂SO₄. Yeah, H₂SO₄ is an acid. This is also kind of an acid, oxoacid. How many H plus does H₂SO₄ give us? Yeah, how many H plus does H₂SO₄ give us? Yes, if I dissociate, no, H₂SO₄, if I dissociate completely, what I will get? If I dissociate H₂SO₄ completely, what do I get? I get the 2H plus SO4 2 minus. Yeah, this is what we get. Yes or no? So we get 2 protons from H₂SO₄. Yeah, if I dissociate H₂SO₄, I get 2H plus SO4 2 minus. Similarly, if I dissociate H3PO2, yes, and Sarjna, Prashanti, Anthony, Sasidaran, How many H I will get if I dissociate H3PO2? Yeah, H3PO2. Yes, Sajna, how many N? How many H I will get? 3,3C. Okay. Now look at the structure. The structure looks like this. See how to draw the structure. How to draw the structure. Okay, look over here. How to draw the structures of this phosphoric acids or oxyacids, oxoacids. Okay, look at the structure. I will draw first phosphorus. Okay, oxygen, always and always remember, oxygen, one double bonded oxygen has to be there. Okay, so double bonded oxygen, oxygen with a single bond. How many oxygen are left? One oxygen is left. So oxygen with a single bond. To that, then after that you add the hydrogens. Okay, how many hydrogens I have? 3 hydrogen. So 1 hydrogen, 2 hydrogen, 3 hydrogen. Okay, 1 hydrogen, 2 hydrogen, 3 hydrogen. Okay, now I have given you the structure. Tell me how many H plus I will get if I dissociate. It is a hint. The answer is not 3. Answer is not 3. No. No Sarjana, no Prasanthi. The answer basicity of this is 1. H plus, which H plus will go? It has to be attached to a strong electronegative element. This one, yeah, only this can go as H plus. Your H₂SO₄, why 2H goes? The structure is something like this. Double bond O, double bond O. H₂SO₄ structure is like this. Double bond O, double bond O. OH, OH. This is a H₂SO₄. That's why the 2 hydrogen you get. Are you getting it? Yeah. Over here, only one hydrogen is attached to the POH. Only one hydrogen is attached to the oxygen. So basicity is 1. These are non-ionizable. These are your non-ionizable. Maximum they can give as H minus. They will not go as H plus. Are you getting it, everyone? Yes. That is why I have skipped the page. I am again coming back to this. Ionizable. This POH is the ionizable group, and that will give you proton. Not all of the hydrogen. Is it clear? And is it clear, Sajna, Prashanti? Is it clear, Anthony? Yeah. So it will only ionizable are OH. Okay. So basicity depends on the POH bond. So pH are non-ionizable. pH are non-ionizable. And similarly, we will come to this in the next structures. Okay. Now H3PO2, it looks like this. Is it clear now how to draw it? Yeah. It is a strong reducing agent. Why? Because it can give you H minus also. Okay. Your H minus it will give and it will reduce the other compounds. That's why it is strong reducing agent. And the basicity is 1. So mono basic acid. That means it gives only 1 hydrogen. That means if you react with base, it will give only 1 proton. Is it clear, Sajna? Yeah. Okay. Chalo. Let's go to the next H3PO3. Now I will not tell you. You tell me, I have told you follow the same method. How many H plus I will get? H3PO3. How many H plus I will get? Draw the structure H3PO3. I have told you method how to draw it. What will be the basicity of H3PO3? H3PO3. What will be the basicity? Very good, Anne, Sarjna, Prashanti, Ragul, Anthony. Draw the structure similarly and tell me. Yeah. Sasidaran, where did you go? Turn on your camera. Do not, I know you have a flap on that camera. Okay. Even I have that. Yeah. Okay. Correct, Sarjana. H3PO3. How we will draw it? Sasidaran. First, draw the phosphorus. Yeah. First, draw the phosphorus, Ragul. Then, draw a double bond oxygen. Then, draw the remaining oxygen with the single bond. Yeah. Then, you add the hydrogen. How many hydrogen I have? 3. So, 1, 2, 3. Yeah. So, what is the basicity? How many proton I will get? Ragul, Sasidaran. 1 and 2. Is it clear, Prashanti? And Sajna, is it clear? Yes, yes. Big trick. Yeah. Yeah. So this is how we will get. Now what is important is you remember the name. That is the most difficult part over here. Okay, that is the most difficult part, not the geometry, not the structure, not the basicity, not the bonds. Drawing structure is easy. If I give you H3PO3, you will draw it immediately. But if I tell you orthophosphorus acid, you cannot, because you need to remember the structure. Yeah. So name and formula is important. Remaining thing you can do it. Yeah. Name and formula is important. So first one was your hypo, or it is also called as phosphinic acid. Hypophosphorus, generally it will come as hypo only. They will not give you phosphinic, but remember it is hypophosphorus. Then we had the orthophosphorus. Yeah, hypophosphorus and the orthophosphorus. And what is the oxidation state of phosphorus over here, everyone? Orthophosphorus. What is the oxidation state? Come on, calculate. Sasidharan, what will be the oxidation state? Calculate. H3PO3, phosphorus oxidation state. Phosphorus oxidation state, H3PO3. Rakul, calculate. Is it -3 or is it +3? Yeah, is it -3 or +3? It is +3. Yeah, I'll take it as X. This is 3 plus 3 into -2 -6. 6 goes that side. It becomes +6 -3 +3. Correct? It is +3. Okay. Similarly, let's go to the next. So this is a dibasic. You have guessed it. Correct? This is a dibasic. Yeah, dibasic, and it is also a reducing agent. It is also a reducing agent. I hope it is clear till over here. Yeah. Now let's go to next. Now these are again important little bit. Okay. Your P2 type of molecules. Okay. Next is your H4P2O5. H4P2O5, little bit different. Please see over here H4P2O5 and H4P2O6. Now what is the difference between them? Okay, what is the difference between them? Look over here. H4P2O5, remember, one with the less oxygen will form a POP bond. One with the more oxygen will form PP bond. Okay. One with the less oxygen will form POP bond. Okay. So over here, H4P2O5, it looks like this. POP. Everything remaining same. Everything remaining same. H4P2O5. Everything remaining same. That means what? I will draw again double bond O. Double bond O. How many oxygen are left? 1, 2, 3 are done. So 4, 5. Then add the hydrogen. How many hydrogen I have? Sasidharan over here, 4 hydrogen. So 1, 2, 3, 4. Is it clear, everyone? Yeah, come on, draw the structure. Come on, give me yes or no. Is it clear? Questions, is it clear? Sarjana. So again, this is a pyrophosphorus acid.
Sir,
Pyro. Yes,
sir,
Sasidharan.
sir, this is Anthony, sir. Can you explain again, sir?
Okay. Anthony, look over here. What is our molecular formula? H4. I'll explain it again. Those who have understood, kindly draw the structure. Okay. What is our molecular formula, Anthony? H4P2O5. Correct. Now, it is little bit different from the other structure. Why? Because we have over here P2. We have P2. And generally, when you have an odd number of oxygen, okay, they form POP bond. They form POP bond. So first, what you will do, Anthony? First, write down POP bond. Okay, now one oxygen is done. Now, always I have told you, Anthony, what you have to do when you have phosphorus. Draw double bond O to that. So similarly, I'll draw double bond O, double bond O. So how many oxygen are left, Anthony? Now 1, 2, 3 are occupied, 2 are left. So one oxygen over here, one oxygen over here. After adding oxygen, what do we write? We write the hydrogen, Anthony. So how many hydrogens we have? We have 4. So I'll add the 4 hydrogen. 1 hydrogen, 2 hydrogen, 3 hydrogen, and the 4th hydrogen. Okay. That is the structure of H4P2O5. So over here, Anthony, is it clear?
Yes, sir. Clear, sir. Thank you, sir.
Okay. So H basicity, Anthony, what will be the basicity? How many H plus it will give? It is attached to O, so that will go as the H plus. So I will get 2H OH plus only. Yeah. So basicity is 2. So again the name is difficult. Pyrophosphorus. Yeah. Pyrophosphorus. Remaining things are easy. Pyrophosphorus. Yeah. Now come on, draw it on your own for hypophosphoric acid. In that you do not have POP bond, you have PP bond. Yeah. You have PP bond. Draw it on your own now. Come on. Easy. Come on, draw it and show me in the camera. Yeah. Ragul, draw it and show me in the camera. Consider draw it. H4P2O6. Come on, draw it and show me. H4P2O6. H4P2O6. Person stay, draw it and show me in the camera. H4P2O6. It will contain PP bond, not POP. It will contain PP bond. Very good, Anthony, show. Very good. Yeah. Come on, show if you have done. To the right, yeah. Correct hand. Yes, Ragul, I'm waiting for your answer. I want to see your beautiful diary, Ragul. That's why I have given this work. Yeah. You know, you all look, while showing homework, you know what you all look like. You look like the jail, the person who goes to jail. Yeah. They give this mug shot, no, with holding that name, age. Yes, Sasidaran, did you get it? Show me your mug shot then. Show the structure, Sasidaran. Okay, very good. Okay. Sajna, done? No? Okay. See if it is correct or no. What we have? PP bond. What is our structure? H4P2O6. H4P2O6. So PP bond. Remaining thing, what you will do, as I told you, first thing, draw the double bond to the P. Yeah, double bonded O. Double bond O. Double bond O. Remaining oxygen, how many oxygens are left? We have 4 oxygen that are left. Correct, Sajna? So 1 oxygen, 2 oxygen, 3 oxygen, 4 oxygen. Simple. Then how many hydrogens we have? We have 4 hydrogen. So 1, 2, 3, 4. Simple. Is it clear, everyone? Yeah, come on, give me yes or no. Is it clear? Very easy. So this questions, I am telling you, so many times it has come. They have asked POH bond, PH bond, P double bond O, POP, PP bonds. They have asked. Okay. And this is the common question. In this, your pyrophosphorus and hypophosphoric. They ask which of them contain POP and which contains PP. Okay. So you should know this. Is it clear till over here? Come on, give me yes, everyone. Is it clear? Sure. Then we have the orthophosphoric. This is very easy. Come on, you draw it now. H3PO4. Quick. H3PO4. H3PO4. Quick. Orthophosphoric. Draw the structure and tell me the oxidation state. Draw the structure. Tell me the oxidation state. Yes, Anthony, draw the structure and tell me the oxidation state.
Sir, no P
Draw.
bond, sir.
Yes, Anthony, what happened?
No P bond.
No P bond. We have H3PO4. No. So you have single P. Okay. So follow our same method. One double bond. Yeah, same method what we have done. Yeah. Come on, draw the structure and oxidation state. Okay. Show me the mirror just a minute. Okay. Very good. I got it. Yes. Yeah, correct. Correct. Sarjana. Okay. Yeah. Okay. Got it. Got it. Anthony, waiting for your structure. Show the structure. Yes, everyone. Oxidation state. Sashidhar and Sarjana, calculate oxidation state. We have not done it. It is R plus 5. Correct? Plus 5. So Anthony, the structure will look like P double bond O. Then how many oxygen left? 3 oxygen. 1, 2, 3. Then how many hydrogen? 1, 2, 3. So basicity is 3. All 3 are ionizable. So this, what is this? H3PO4. It is a phosphoric acid. A strong acid because it ionizes all the hydrogen. Yeah, are you getting it? Yeah. So yes, this is your orthophosphoric acid. Orthophosphoric acid. Is it clear, everyone? Yeah. Then you have the H4. This is not O2. It is P2. Okay. Again, the odd number of oxygen has come. Again, if you notice, POP. Come on, draw it. It contains POP bond. Come on, draw it. POP. And can you draw it now? POP bond. Okay. H4 P2O7. Okay. Draw the structure and tell me the oxidation state in the chat box. Draw the structure. Sashidharan, you are not drawing. Draw the structure and tell me the oxidation state in the chat box. Very good, Anthony. It is not clearly visible, but yeah, I got it. Correct. So I'm H4P2. Okay, correct. POP bond. Okay, very good. Okay, very good, Sarjana. Okay. Fine. Yeah. So we have a POP bond again. POP double bond O, double bond O. How many oxygens are left? H4P2O7. 4 oxygen are left. So 1, 2, 3. Correct. Prashanti, 4. Yeah. So how many hydrogen? 1 hydrogen, 2 hydrogen, 3 hydrogen, 4 hydrogen. Perfect. Yes. And oxidation state is plus 5. Is it clear, everyone? Yeah. So these structures are important. I hope you are able to do it. Only thing again, this is a pyrophosphoric acid. You have to remember the name. Yeah, that is the only difficult part you have. That's it. Only difficult part is the name. Yeah, this is tetra basic. Then you have the metaphosphoric, same thing. Now do not draw it enough. HPO3, so P double bond O, O, O. So O3 na ha, O, O. So hydrogen over here. Now HPO3, only one hydrogen, is it? No. Actually, this is HPO3 thrice. HPO3 thrice. It is kind of a polymer of your HPO3. Okay, it looks like this. Look over here. HPO3 thrice. This is not an open structure. This is a cyclic structure. It is kind of a polymer of HPO3. Look over here, everyone. Same thing. Same thing. Okay, same thing. It is also important, market important HPO3. It is called as trimetaphosphoric acid. Okay, HPO3 thrice. HPO3 thrice. It is also exact same structure. Only thing is it is a cycle. It contains what? Again, see how to draw this. Again, P, P, P bonds. Okay, yeah. HPO3, odd number of oxygen. Again, POP bond. O, O, correct. O, O, correct. Then we know it contains what? Double bond O, double bond O, double bond O. Now how many oxygens are left after this? 1, 2, 3, 4, 5, 6 are done. HPO3 thrice. That means 3 oxygen are left. So 1 oxygen, 2 oxygen, 3 oxygen. How many hydrogens we have? We have 3 hydrogens. 1, 2, 3. Getting my point? Is it clear? Okay, it looks complex, but it is not. Very easy. Yeah, very easy. Okay, so if we hydrolyze it, if we further polymerize it, no, to HPO3N, it becomes an open chain structure like this. Okay, but you remember the ring chain, that is fine. Your metaphosphoric acid. Metaphosphoric acid. Come on, draw the structure and tell me done. Draw the structure and tell me done. Come on, everyone. Draw the structure and tell me done. Draw the structure. Sarjana is done. Anne is done. Come on. Sure. Let us go ahead. Sasidaran is also. Okay. So this are all the structures we have done already. Yeah. So oxoacids. Yes, oxoacids. All of these oxoacid. Either the common oxidation state is +3 or +5. If you look at the table, yeah, all the oxygen, all the phosphorus generally they might be in +3 or +5. Now these are some of the prefix. Now meta acid is used for when you lose one water molecule. Yeah, that when you add those phosphorus acid, if it contains one less water molecule, we generally call it as meta. So pyro is obtained when you heat it and two molecules with loss of one water. Do not remember this, very confusing. Yeah, remember the name directly with the structure. This is a very confusing. Okay, this is kind of a trick, but I don't think so you should follow this. Remember the name regularly, you will get it. Okay, do not remember this trick. Okay, question, let us come over to this afterwards. Let us finish the part first. Yeah, now chalcogens. Yeah, your group 16. Now remember always one thing, that first element is the head of the family. Yeah, you also call it as a oxygen family, just like you have a like head of family, correct? So the people when they walk, this is his family, like that. Oxygen is the head of the family. Whatever the first element do, we give them the head of the family status. We call that group by that name also. So group 16 is also called as oxygen family. And remember this name, chalcogens. Group 16 are also called as chalcogens. Okay, group, write it down somewhere. Can come in the master column. Group 16s are also called as chalcogens. Group 16 elements, they are also called as chalcogens. Now, most abundant, we all know, everyone, yeah, we have discussed this in metallurgy, I guess. Yeah, the first lecture of metallurgy. The most abundant element in the universe is what? Sasidaran, Sarjna. Most abundant element in the universe. Yeah, most abundant element in the universe. It is what? And Sarjna, Sasidaran, the most abundant element in the universe. That was a trick question. It is not oxygen, it is hydrogen. On the earth surface, on the earth, yeah, on earth it is oxygen. Yeah, on earth it is oxygen. Anthony, correct. The most abundant in the universe is the hydrogen, but on the earth the most abundant is oxygen. Most abundant is oxygen. So you have all the sulfur is the 16th most abundant, and look at the coincidence. Yeah, what is the atomic number of sulfur? You can remember like this. Yeah, 16th abundant and 16th atomic number. Yeah, so sulfur exists as a sulfates and sulfides. Yeah, sulfates and sulfides. We will see all this in the reaction. Okay, now your livermorium. Yeah, why we do not talk about livermorium much? Because it is a radioactive and it has very short half-life. Yeah, I hope you all know what is half-life. Yeah, it goes on decaying by eliminating alpha beta particles. It goes on decaying till it will not exist. Yeah, so it has very short half-life. It comes and immediately goes away. Okay, it comes and immediately goes away. So those are your chalcogens. Now electronic configuration. I hope everyone knows how to write down the electronic configuration. Yeah, we have seen the triangle. Yeah, from the triangle everyone can draw the electronic configuration. I hope everyone knows how to remember the atomic number also. I have told you about the magic numbers 8, 18, 18, 32. Yeah, 8, 18, 18, 32. Yes, 8, 18, 18, 32. That is how you remember the atomic number also. Okay, so please remember this important. Yeah, we have learned the p block elements also in the first lecture. We have covered a lot. I am telling you, we are covering a lot of things. You have to revise, otherwise it is complete waste. Yeah, chalo. Now let us study about their properties like atomic radii, ionic radii. Yeah, let us study about their properties quickly. We have a table, I guess. Let us focus on this. Okay. So atomic number we have studied. Atomic mass, obviously, as we go down the group, the mass will increase. Now look at this covalent radius and the ionic radius. What is an ionic radius, everyone? What do we mean by ionic radius? Yeah. What do we mean by ionic radius? How it is different from covalent radius? Yes, how it is different from covalent radius.
So when an electron is added or removed from covalent, like not from an atom, like its atomic radius changes to ionic radius.
So basically it is the stable ion of that atom. Okay, like for example, okay, like your sodium. Okay, for ionic radii we look at Na plus. Now when you go from Sarjana N, when you go from Na to Na plus, the size decreases. Why the size decrease? Because there is a tremendous decrease, because you remove completely one shell. Yeah, sodium is 2,8,1, Na plus is 2,8. Yeah, you remove completely one shell, so size decreases. Same thing over here. When we add electrons, the shell does not get added, but due to the repulsion, the size increases. And look at the difference. Look at the difference in the ionic radii. Yeah, tremendous. Why? Because you are adding two electron, and two electron adding is not an easy task. Yeah, so it increases the size a lot. Okay. Now ionization enthalpy, again. Ionization enthalpy means energy. Ionization means to remove an electron. So as you go down the group, everyone, the size increase. If the size increase, is it easy to remove a last electron, or is it difficult? If the size increases, Sarjana and Sasidharan, if the size increases, is it easy to remove the electron, or is it difficult to remove the last electron? Correct? It is easy, because positive, negative, they are going far, far, far from each other. Correct? So it is easy to remove electron. Therefore, the energy, Sasidharan, the energy that is required to remove that electron is very less. The energy that is required to remove that electron is very less. Okay, and that is why as you go down the group, the energy is going on decreasing, because easily the electron is going away. Is it clear, everyone? Yeah, is it clear? Now over here, electronegativity means what? It is obviously, as you go down the group, it decreases. Fluorine, chlorine, bromine, iodine, similarly oxygen, sulfur, selenium, so it goes decreasing. Now electron gain enthalpy, when you add the electron, how much energy is absorbed or released? That is your electron gain enthalpy. Okay, oxidation state, we will come to this. Now anomalous behavior of oxygen. First of all, similarly like nitrogen, if you remember when we're doing the group 15, I told you the main thing, okay, the anomalous, why we are calling it as anomalous? First of all, anomalous means something different. Now what is different is the number. If you look at the electronegativity, yeah, oxygen is 3.5. Yes, it is following the trend, but after 3.5 you have 2.4, 2.4, yeah, 2, yeah, 1.7. It is in the range. Okay, but when you come from oxygen below, it is more than 1. The difference is more than 1. Same thing, if we look at ionization enthalpy, yes, it is decreasing. Over here, difference 100, difference 50, 100, 50, 100. But look at this difference, 300. Yeah, that is what we are calling it as anomalous. Oxygen itself is not behaving like it is not anomalous, means something different. It is not exception. Are you getting it, everyone? Over here, what is the meaning of anomalous? Now this is happening because the size of oxygen is small. Yeah, the size of oxygen is small. That is the main reason, Sarjana, why it is behaving differently. Okay, and different means what? Whatever trends it is following, the number is very small or very high from others. That is the only difference what we have. Okay, so that is same case with the nitrogen, that is the same case with oxygen, that is the same case with fluorine. Okay, all of them, the first element, okay, the first element, boron, carbon, nitrogen, oxygen, fluorine, all of them size is very small. Okay, and they do not have 2D. Yeah, so that's why they behave anomalously. Is it clear, everyone? Yeah, is it clear? Come on, give me yes or no. Is it clear? Yes, I hope it is clear. Okay, chalo, let us go ahead after this. What we have? Hydrides. Hydrides, again important. Okay, hydrides. Hydrides. Okay, hydrides. So, hydrogen bonding. We do hydrogen bonding before? Yeah, we have done this in the nitrogen group also, hydrogen bonding, correct? So now let us talk about hydrides of group 16. Hydrides of group 16. Okay, now over here, as you go down, what do you think? What will be the reason your acidic strength increases? Yeah, Sarjana and Sasidharan, Anthony, what do you think? Why your acidic strength, Anthony? Where is your focus? Look onto the screen. Keep the mobile aside. Yeah. As you go down the group, why acidic strength is increasing? What do you think? Yeah. Why acidic strength is increasing? Sarjana, what can be the reason? Sasidharan, why acidic strength is logical reason? Logical reason. What is an acid, everyone? You'll get your answer over there. How do you define an acid? Acid is a substance that acid, yes, acid is a substance that Sasidharan, acid is a substance that they're ready to give electron. No, we are not talking about electrons over here.
Sir, as
Correct.
loses H plus.
Yes. So as you go down the group, what is happening? Sasidharan.
Ability to lose H plus ions increases.
Exactly, but why? Yes, exactly. That is what I am also saying. But why? Why, if you go down the group, the ability of lose H plus to lose H plus is increasing? See, simple. When you go down the group, Sasidharan, what is happening to the size?
Increases.
Yeah. Ah. So obviously, if oxygen is there, hydrogen is like this. Okay, they will form a bond. Sulfur is bigger than the oxygen. Okay. Then you have the selenium bigger than the hydrogen. Okay. Then you have this. Okay. So obviously, as the size increases, Sarjana, Sasidharan, what is happening? This is easy to break. More easy to break, more amount of H plus will release. Yes or no, Sasidharan? Are you getting it? Yeah. Is it
Sir,
clear
so
now?
due to the large size of the atom,
Yeah.
dissociation becomes easy.
Yeah. So that's why the dissociation becomes easy. That means more H plus will be released. Yeah. So yes, that is how the acidic strength increases. And that is the reason thermal stability decreases. As you go down the group, heat it, immediately it will break. Yeah. Thermal stability decreases. Is it clear, Sasidharan, now?
Yes, sir.
Yeah. So that is how your hydrides work. Yeah. So that is how your hydrides work. So if you see the bond distance, but again it shows a little bit exceptions. I'll tell you what. Okay, important exception. So again, bond distance, as you go down the group, the size increase. Bond distance, what is happening to bond distance? Yes, bond distance is also increasing. Yes, we have discussed this. Bond distance is also increasing. Now the exception is what? If the bond distance is increasing, it should easily break. But look at the melting point. Yeah, melting point differs. Okay, melting point differs little bit. See, it follows the trend. If you go down the group, melting point should decrease. Yeah, melting point should decrease because thermal stability is decreasing. But H2S, H2S, slightly different behavior. Yeah, from 273 it becomes 188, 208, 222. Yeah, from H2O to H2O2E it decreases, but not in a linear method. Okay, not in a linear method. Remember, like this: 273, 188, 208, 222. Okay, kind of an exception. So inorganic and exception goes hand in hand. Yeah, so you have to remember that.